Hey guys, today I'm going to teach you how to subtract rational numbers. So by the end of this lesson, you'll be able to use models and algorithms, which are just rules, to add and subtract integers, fractions, and decimals. So previously we were just adding rational numbers. Now we're going to be able to subtract all kinds of different rational numbers, and you'll realize it's pretty much the same as adding. So go ahead and get out your binder, turn to the math section, and get ready to take some notes. Before we begin, go ahead and flip back to the previous intro to rational numbers or the last lesson. And what I want you to do is jot down the process for subtracting fractions and decimals. So we talked about this in the intro to rational numbers. You might want to flip back, go ahead and pause the video, write that down, and then come back to check. So we'll go ahead and start with fractions. First, you have to find the least common denominator. LCD stands for least common denominator. It's like the least common multiple, but just for the bottom of fractions. This time we're subtracting the numerators, but we'll still keep the denominator the same. Let's look at it for decimals. For decimals, we just line up the decimals vertically. We insert placeholders if needed, so those zeros, and then we subtract. So when subtracting, we'll use the additive inverse to add the opposite. That just means that we are not going to subtract. We can always change a subtraction problem to a plus the opposite. So we're going to use our understanding of zero pairs, opposites, and additive inverses. They're all the same thing. To realize that we're not going to subtract, we're going to add the opposite. Keep, change, change. Remember? To start out looking at subtracting integers, we'll just remember that we rewrite the problem to add the opposite, then follow the rules for adding integers. So we aren't subtracting, we're going to change our subtraction problem to add the opposite. So right here where it says 7 minus 16, we're just going to keep the first number, and then we'll change to a plus, and the opposite of 16 is negative 16. So we're going to keep, change, change. Now that we have this written as an addition problem, we'll follow our rules of adding integers. So look back in your notes if you need to, but whenever there are opposite signs being added, that means you subtract the numbers. So 16 minus 7, 16 minus 7 gives you 9, and then you take the sign of the number with the greatest absolute value. So you look at the two values of the numbers, you can see that there's more negative 16s, there's more negative numbers than there are positive numbers. So your answer will be negative. Let's look at the next one, and if you are good at these, you can go ahead and try these yourself and then press play when you're ready to check. But we'll keep the first number, we'll keep the negative 8, we'll change the minus to a plus, and we'll add the opposite. So the opposite of 11 is negative 11. So now you have a negative 8 plus a negative 11. So if they're the same sign being added, you add like normal. So 8 plus 11 is 19. And then they're both negatives. You owe $8 and you owe 11 more. So your answer will be negative. Let's look at the next one. You're down 3, you go down 12 more. So if you're just thinking about this one already with a word problem, you can realize that this is going to be down 15. But I'll go ahead and do it with the rule or the algorithm. Negative 3 is kept. Change the minus to a plus. And then the opposite of 12 is negative 12. So negative 3 plus negative 12, they're the same sign. So you add like normal and get 15. And then you keep the sign. So by now we've done 3 examples. You definitely want to try the rest by yourself and then go through, press play, and check. So pause now to try the rest by yourself within this section and then press play when you're ready to check. Okay, so by now you should have tried all these. So we're going to go ahead and do 5 minus 13. We're going to change this to a plus the opposite. So we keep the first number and we add the opposite. We always want a plus negative when we see minus. So you have a 13 and you have a 5. They're opposite signs. So you want to subtract. So 13 minus 5 is 8. And there's more of the negatives than there are the positives. So my answer will be negative. Let's look at the next one. We keep the first number, change the minus to a plus, and then we add the opposite. So we always want to keep the first number and add the opposite. Now that this is written like an addition problem, we're going to follow our rules for adding integers. So when they're different signs, we're actually going to subtract. So 17 minus 3 is 14. And then we're going to keep the sign of the number with the greatest absolute value. So 17, there's more negatives. So we'll keep this to be a negative 14. Let's look at the next one. Already you should start to see Bob. When you see a minus minus, you should start to realize that there's a pattern here and you should know to do something. But I'll go ahead and work it through. I'm going to keep the first number. And I'm going to change the minus to a plus. And I'm going to add the opposite. So the opposite of negative 10 is 10. So this problem is really 2 plus 10, which is 12. So keep, change, change. You also just want to remember when you see a minus negative, you're always going to add. So let's use that information for the next problem. 8 minus negative 17, or 8 take away the negative. When you take away a negative, you have a positive. And then we'll just always follow this algorithm. So in case you don't understand, we'll just keep it simple. Keep, change, change. So I kept the 8, changed the minus to a plus, and then change the number to its opposite. So 8 plus 17 is the actual problem here, which gives me a sum of 25. Let's look at the next one. You have a negative number to start with, so we always keep the first number, change the minus to a plus, and then we add the opposite. So since it's a minus 14, we add a positive 14. When there are different signs being added, as they are here, you want to subtract. So 14 minus 9 gives you 5, and then we'll keep the sign of the number with the greatest absolute value, which is 14. Let's look at the next one. Keep the negative 16, change the minus to a plus, and then instead of adding negative 7, we're going to add a positive 7. Keep, change, change. So since there are different signs being added, we're going to subtract. 16 minus 7 is 9, and then we'll keep the sign of the absolute value that is bigger. So 16 is the bigger absolute value, and it's negative, so it'll be a negative sum. Let's look at the next one. You have negative 15, and then there's Bob. Look, minus minus. So we're going to know to add 4. So negative 15 feet underwater. I swim up 4 feet. I'm still underwater. I'm underwater 11 feet. So the same will be true for subtracting decimals. We rewrite the problem to add the opposite, then follow the rules for adding rational numbers. So we're going to do the same thing that we just did for that section. We'll do it with decimals now. So we always keep the first number, 4.5, and we change the minus to a plus, and we add the opposite, so 6.3. Then we're just going to follow our addition rules. The two numbers that I'm adding have different signs. If they have different signs, I'm going to subtract, and I'm going to subtract vertically since they're decimals. So go ahead and get your whiteboard out or a piece of paper, and you want to rewrite this problem vertically. And you want to write this problem as a subtraction problem. Go ahead and try this and press play whenever you're ready. We want to go ahead and make sure that we are subtracting straight down, starting from right to left this time. So we'll look at here, and can we take 5 from 3? No, so we have to borrow. You borrow from your neighbor by taking 1 away from it, making it from a 6 to a 5 here, and then adding it on to the tens place here. So now you're taking 5 from 13. So 5 from 13 is 8. And then looking over next door, you see a decimal. Keep the decimal in the same place. Then 5 minus 4 is 1. So your answer is 1.8. So we're going to write 1.8 and look back at the problem. So we're using our addition rules. When they're different signs, I subtract and then keep the sign of the greater absolute value. So 6.3 is the greater number, and it's negative. So my answer is going to be negative. As you can tell, this is getting very repetitive. You're going to do the same process that we've been doing for all these problems, so I'm going to skip around. So I'm going to do one more in this section. I want you to try the rest by yourself, and then we can check in class. So let's go ahead and look here. Let's do 2.5 minus negative 6.5. So when you see a minus negative, you know that means plus. But in case you forgot, we're just going to follow our rules. It says rewrite the problem to add the opposite. So we're going to rewrite this, keep the first number. We're going to add the opposite. So the opposite of negative 6.5 is positive 6.5. We'll line up our decimals and add like normal now that we have two positive numbers being added together. You could write it like this vertically, or you could write 6.5 plus 2.5. They're the same thing. Either way will get you the same answer. 5 plus 5 is 10, and then 6 plus 1 is 7, plus 2 is 9. So you have 9.0, or just regular 9. So the answer to this problem is 9. So again, we'll be able to go over the rest of these. I want you to try this section by yourself, but I'm not going to go through any more of these in this video. Now we're going to look at subtracting fractions with like denominators. The process for fractions is the same. It just requires a couple more steps. So I'm going to do 2 practice problems for you, just like the last set. If you want to try all of these by yourself first and then check along with me, you can, but I'm only going to go over these 2 in the video and then the rest in class. So it's the same strategy. We rewrite the problem to add the opposite, then follow the rules for adding fractions. So we'll go ahead and just rewrite this first one as 3/5. We keep the first number, then we add the opposite. And now we're looking at a problem like we did when we were adding fractions. We have 2 fractions that have different signs, so we're going to subtract. So we'll do 4/5 minus 3/5. which means that we're only going to subtract the numerators since they have matching denominators. So 4 minus 3 is 1 out of 5. And since this negative 4/5 is more than 3/5, we're going to keep this 1/5 negative. So negative 1/5 would be your answer to this problem. Let's look one down and let's look at negative 2/3 minus negative 1/3. When you see a minus negative, you want to add, but we can realize that by following the rule, rewrite the problem to add the opposite. So we're going to add the opposite of negative 1/3, which is positive 1/3. We'll see that these are different signs, so negative plus a positive. So we're going to subtract, and then we're going to keep the sign of the bigger number. So 2/3 minus 1/3 is 1/3. And since there's more negatives than positives, our sum will be negative. So negative 1/3 is our final answer for this problem. Okay, so let's go ahead and look down. We'll go over the rest of those in class. Let's look down at the next section. We'll now subtract fractions with unlike denominators. So we'll follow a few different, the same steps, but just one extra thing. We'll have to find a common denominator first, just like we did when we added fractions. Then we'll rewrite the problem to add the opposite. Then we'll follow the rules for adding. So all this is just following steps. Can you follow the steps for this? So I'll do one. Let's look at the last one. It's the hardest one on here. So we're going to keep the negative 1 1/2. We're going to change it so that it's adding its opposite. So instead of minus negative, it'll be plus plus 4/5. Whenever I add fractions, I don't want to add them until they are both fractions, not mixed numbers. So I'm going to go ahead and do my process to turn a mixed number into a improper fraction. So I'm going to multiply 2 times 1, which is 2, plus 1 is 3. So I have 3 halves. Remember, this was negative, plus 4/5. And that negative sign for the 3 halves can go onto the 3 or onto the whole fraction. It might be easier just to look at it just on the top, just on the 3. So we've kind of jumped ahead to the rewriting the problem to add the opposite section, but let's look at this first one that says find a common denominator. So now they're written as improper fractions. I need to find a common denominator between 2 and 5. Go ahead and think to yourself, solve the rest of the problem, pause the video, do what you need to do. Whenever you're ready to check it, press play, but you can do this part by yourself. So you should have realized that the number that 2 and 5 both go into is 10. You can get to that for the 3 halves by multiplying by 5. So whatever you do to the bottom, you do to the top. So we multiply by 5 to get to 10. So we're going to do it to the top. So 15 over 10 is our equivalent fraction. We're going to multiply 4/5 by 2 over 2 to get it to have a denominator of 10. So an equivalent fraction for 4/5 is 8/10. And then we're going to add. So whenever we look at our instructions, it said follow the rules for adding. So you might want to flip back in your pages to adding fractions that have different signs. You're going to subtract. So we're going to do 15 minus 8, which is 7. We're going to keep the 10. We keep our denominator when we do fractions. And then you take the sign of the number that has the greatest absolute value. So this 15/10 is more, and it's negative, so your answer will be negative. So all that work got us negative 7/10. Try the rest by yourself, and then we can check in class. All right, guys, that's it. If you made it to the end of this video, please put the funniest joke you know in the comments. Make sure it's appropriate. Today, we went over subtracting rational numbers, so now you should be able to use models and algorithms to add and subtract integers, fractions, and decimals. So now, I want you to go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!